Hi everyone! In this video, we are going to be talking about end behavior of polynomials. So first things first, we need to understand the notation behind end behavior because if you don't understand the notation, you probably aren't going to understand the concept itself. And the notation, while it's something we've looked at previously, it is something that looks pretty different from other mathematical notation you've seen in the past. So I wanted to go through this and really practice saying out loud what is meant by this notation. So first, we are going to look at the notation right here. And underneath that, I have written in quotes the way you would read this out loud. So the way this is read, and as I read this, I'd like you to look at the notation I just circled and try to follow along there. But this says, as x approaches negative infinity, f of x approaches blank. Okay. So the key part here is that the arrows, right, those are read aloud as the word approaches. Okay. And that is very key because we have to understand what that means. On the next slide, we'll look at an actual graph and look at that in context. But again, to know that the arrows mean approach, that really helps us understand this concept. So I'm going to now read this part here out loud. And that says, as x approaches infinity, f of x approaches blank. Okay, so as our x value becomes infinity, so as x gets really big, what happens with f of x, which is just my function? Well, what's the value of my function? Where is it headed? Okay, and that's what is asked here. Now, I know this might seem silly, but if you are having trouble with these concepts, I suggest you literally practice like reading these things out loud. If we were currently learning this in the building versus being in distance learning, you guys would have plenty of practice saying these things out loud and it would really help solidify. But I do recommend even sitting at home at your computer, you just pause this for a second and practice saying these things out loud so that the way they're read really sticks out in your mind. Okay, so now we're going to look at an example because I think this will help this all make more sense in context. So first, what I'm going to do, we have to understand the concept of infinity and where that falls on the graph as well as negative infinity. So I'm going to go ahead and label my axes. So I know that my axis that goes left and right, this is my x-axis. And I know that my axis that goes up and down vertically, that is my y-axis. And so I'm just going to go ahead and start labeling. We know that the cross of these two axes is 0. As I move to the right, I have 1, 2, 3, and 4 on the x-axis. Now, if I were to keep numbering, it would just keep going up by 1 unit at a time. 4, 5, 6, 7, 8, 9, 10, 11, 12, right? And it's just going to keep going and keep going and keep going. And as I extend this somewhere way off down here, essentially x becomes infinity, right? There's a certain point, right, where we're saying, well, way at the end, it's not a definite number, but essentially it just keeps going forever, and the value it reaches at forever is going to be infinity. Okay. And then I'm going to continue labeling x in the negative direction. So we have -1, we have -2, we have -3, -4, -5, right? -6, 7, 8, 9, 10, right? You just keep going further in the negative direction. And this graph expands, even though we can't see it, and it keeps going further and further and further in the negative direction. And to the far side over there, right, we would refer to that as negative infinity because it keeps going infinitely far in the negative direction. It goes forever. But again, it doesn't go forever in a positive direction. All numbers on that side are negative. So what that represents is a really, really, really negative number, right? And that's the distinction between negative infinity versus positive infinity. Right? Now, I'd also like to go ahead and label like this for the y-axis, and I'll do that a little bit faster. But as you go up this y-axis, right, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, right? And as you go up and up and up and up, at the very top of your graph, you're looking at an increase infinitely going up forever. So we would say that that high y value up at the top of the graph, that is infinity. Okay. On the other hand, as I work my way down this graph, right, I have -1, -2, -3, and if I kept going down, -4, 5, 6, 7, 8, way, way, way down, and it keeps going down forever. And because I'm on the negative y values, way at the bottom is considered negative infinity. It goes infinitely far in the negative direction. Okay, right, and that's just sort of a continuation of the y-axis. Now that we have that labeled, let's talk about what this notation means again. So over here on the left, this first part here, this is saying as x approaches negative infinity, f of x approaches what, right? So basically we're saying as x goes to negative infinity. Well, what does that mean? The x-axis is this axis that goes left and right. Okay, right? We labeled that this is the x-axis. Okay, it goes left and right. Well, as x goes to negative infinity, I'm talking about way far to the left on the x-axis. I'm talking about way out here to the left. So sometimes we actually also will refer to this as left end behavior because it occurs at the end of the graph, right? And which side of the graph I'm on depends on what value x is approaching. So since x is approaching negative infinity, this is left end behavior. And basically what that means is that it's asking us, what is the behavior of the graph? What is happening with our function at the left side, right? So as I approach negative infinity, as my graph is continuing in that direction, right? As I'm moving towards the leftmost part of my graph, what is happening with this function, right? It sort of continues off the graph there. And you see how when I'm drawing this arrow, that's the continuation of this function, that arrow is pointed down. Okay, it's pointed slightly left because I'm obviously moving in the left direction, okay, but it's pointing down to indicate that my function is going to keep decreasing forever. And as my function, right, or f of x, decreases and goes down, 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 down to the bottom of the graph, we see how the y value would approach negative infinity, right? Negative infinity is at the bottom. So any value at the very bottom of our graph, regardless of where we are in x, the bottom of the graph indicates a negative infinity y value. And that y value is really what's being asked by f of x. When it asks the behavior of the function, right? Because f of x, that's just function notation. Essentially, f of x represents y. Okay. Now that we have that, we can go ahead and look at the other end behavior. So right here, it says as x approaches infinity. So what does that mean as x approaches infinity? Well, I'm back to the x-axis, and I'm like, where is positive infinity on the x-axis? Right, so I'm on the x-axis. Well, I have to go all the way out here to the far right in order to have an x value of infinity, right? So the far right has the highest possible positive values of x. So that is where it's infinity. So this is what we would call right end behavior. Right? And so that means that when I'm asking as x approaches infinity, I'm really asking about what is happening with this function as I go to the rightmost part of it, right? So my x is increasing as I move towards the right, towards infinity. So at this point in the graph, on the right side of the graph, what is happening with the value of my function? Or in other words, the y value. Okay, and you see how this arrow I just drew at the right side of the graph, it's pointed upwards. And that indicates to me that my function is going to continue in this upward direction for the rest of its life, right? As you keep moving right, it's just going to go up and up and up further. And what is the highest y value I reach when I point towards up, up, up on the graph? Well, that would be positive infinity, right? And so that is what I will put here. As x approaches infinity, f of x approaches infinity. And again, that means as I move to the right side of the graph, my function goes up and up and up until infinity. Okay. Looking at another example here, this graph's a little different. We're going to approach the end behavior in the same way, right? So as x approaches negative infinity, well, I have an x-axis here. Right? I know my negative values of x are going to be on this left side of the graph, so negative infinity is all the way over here. That is my left end behavior. Okay? So I'm asking myself, what is happening on the left end of this graph? right? Well, the left end I'm seeing is going like this. It's going up, 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 up. It's just sort of headed off the end of the graph. I know that that indicates to me that this continues, and it continues up high. It's going up, 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 right? And up is the positive direction. So as this continues up infinitely, right, it continues up forever. That indicates eventually, right, what that true end behavior is that it will just keep going. So we say that my function f of x will approach infinity. So as x approaches negative infinity, my function approaches positive infinity. Okay? And again, there's nothing to memorize. It's not like you're always going to have a negative and a positive match together or a positive and positive match together. You really just have to think about, what does this part mean? What does it mean as x approaches negative infinity? Well, that means moving to the left. And then what is happening on the left side of my graph? And then I'm going to do the same thing with the other end behavior, right? It says as x approaches positive infinity, okay, so positive infinity is somewhere out there, right, on that x-axis that goes left and right, but I'm now on the far positive side or the far right. So I'm asking, what is the behavior of my graph on the far positive portion? So towards the right, I see my function moving in this direction. Okay, it sort of heads off the graph and up. This time, my function is also going up. Okay, so my function is going to increase infinitely on the right side, which means that my function is approaching infinity. So in this case, on both sides of my function, we're headed to infinity because both sides, both of those arrows are pointed in the upward direction. We'll look at a couple more examples. So here, I don't have it split up like one on the left, one on the right. That's sort of like an easy hack or cheat. Please make sure you're not just always assuming the first end behavior is left end behavior, right? They're not always going to be drawn one at the left, one at the right, and they could switch orders. So I'm going to always read the statement sort of aloud to myself and see what is being asked. So this first one says as x approaches negative infinity. So again, negative numbers are on this left side of the graph. So negative infinity would be somewhere out over there. So this is in fact left end behavior coming first. So I'm being asked what happens with the function at the left side of the graph. So over at that left side of the graph, I see it going down. Right? This is the left part and it is headed in the downward direction. I know that the bottom of the graph is the negative portion, right? Those are the negative numbers. So as I go down and down and down infinitely, I reach negative infinity. Okay. And then I can look at the other end behavior. So as x approaches positive infinity, I know all these positive numbers, they are on the right side of the graph. So positive infinity means moving in the right direction. Okay. And on that right side of the graph, if I look at what's happening at the end, right, hence end behavior, it's the ends of the graph. On the right end of the graph, I am going down, 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 down. And again, down is a negative place. So eventually it's just continuing downwards infinitely. So its end behavior is negative infinity. Let's do one last example before we end this video. So here again, we have the end behaviors listed. I'm not going to memorize and assume one is first and one is second. I'm going to actually use that vocabulary I know to check. So this first statement reads, as x approaches infinity. Okay, well, this time x is approaching positive infinity first. Well, I know my positive numbers are to the right, so infinity is over to the right and negative infinity is to the left. So as x approaches infinity, I'm actually starting with my right end behavior, which means I have to say what is happening with my graph at the far right side. And over at this far right side, we can see it's sort of like headed off the graph, right? So I draw an arrow, right? I know that my function is just continuing. It just sort of got cut off the graph, but it continues up forever. So if I'm continuing upwards infinitely, then I approach infinity. In terms of my next end behavior, I'm assuming it's the left one, right? I already did right, but okay. As x approaches negative infinity, yeah, negative infinity is going to be over here at the left. So this is my left end behavior. And as x approaches negative infinity, On this left side, what is happening with my function? Well, it appears to be going downwards. So as my function goes down, 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 down infinitely, again, down is negative y values. So I'm approaching negative infinity. Okay. Hopefully, if you were confused at end behavior before, this cleared things up. If you still have questions, always feel free to reach out via email or come in at a student support time, and I would be happy to help you.